once we create the truth table, we have to consider the two possibilities. If the input signal is having the value of 0 or the value of 1. The value of 0 is going to match 0 volts, and the value of 1 in a digital signal matches the value of 5 volts as represented on the diagram below. Considering this, we will move to the next step, which is creating the actual truth table, and here is what we have. The input signal, the enabling input signal, could have a value of 0 or 1, and because we are talking about active high decoder, the value of 0 for the EN signal is going to respond to input combination, which is our don't care. So S1 and S0 are going to be noted in the truth table with X values. The respective outputs Q0, Q1, Q2, and Q3 are going to be also all of them zeros, so we are not going to have an active output on that particular row. When the input enabling signal is having a value of 1, so it is a high signal, then the S1 and S0 inputs are going to follow the 2 to the power of n rule, so it's going to be 2 to the power of 2, giving us 4, so 2 zeros, 2 ones in the column for S1, 0, 1, 0, 1 in the column for S0. And because we're talking a decoder, we have to make sure that we have the identity matrix completed in here. So our main diagonal is going to be completed with the values of 1, and all the other values in the output part of the truth table are going to be 0. Considering such distribution, we can organize the actual graphical presentation of the decoder. So we will move ahead and organize one rectangle, which is going to represent the decoder. It will have 3 inputs, S0, S1, and the third input is going to be tied up to the enabling signal. The 4 outputs are going to be Q0, Q1, Q2, and Q3. So here is what we're getting. The graphical presentation of the decoder clearly shows that we're having the 2 inputs, the 4 outputs, and highlighted in red in here is the enabling input signal with the value of 1. Because we're going to have implementation of that decoder using active enabling signal of 1, and we have to use respectively the AND gates, we can pull the expressions for the respective minterms as multiplication of the 2 input signals. The respective minterms we're looking at are developed using the truth table for the outputs. As you can see, comparing the truth table with the final results, it is clear that we're going to move on to a logic gates from here using AND gate. This will resolve our question.